and Sarah already alluded to this, that we're going to go through the 1.5 degree.
She didn't allude to it. She drove through it with a bulldozer.
Yes.
Aditya passes the mic to Andrew with a meaningful
Very
look.
quickly.
This is your problem, boss.
Yes.
Yep. Good luck.
Thanks.
I'm Sarah Perkins-Kirkpatrick.
I'm Iain Strachan,
And this is Totally Cooked.
the Climate and Weather Podcast. Today we're joined by Associate Professor Andrew King and PhD student Aditya Sengupta.
Okay, so Aditya, everyone must have heard this term once, being net zero. But what exactly is it?
Net zero has been in the news for a while. And what it essentially means is that it's a balance between how much we emit into the atmosphere, humans emit, and by emit, I mean greenhouse gas emissions, and how much is uptaken naturally or artificially by us again. And when it is in a balance, that's when we call it net zero.
Is it in a balance?
It's not in a balance.
It is not in a balance.
It's definitely not in a balance now.
Yeah, and hasn't been for a while.
When you say emit, so is this from like human activity, or we're also talking about natural emissions as well?
Yeah, there can be natural emissions there. For example, wildfire can lead to emissions. And there can be emissions because of land use changes, which could be artificial or natural. But then there's also, but of course, the biggest contributor is anthropogenic or human-caused greenhouse gas emissions.
We're winning.
This is not a race we want to win.
It's not something you want to win.
Oh. Andrew, do you know when we first started talking about net zero? Like, I feel I've known this term for a while, but I don't know when it appeared. Do you remember?
I actually don't know.
Neither do I.
All right, cancel the podcast. You two need to resign, and I'll supervise Aditya from now on.
The climate scientists are shit. They don't know anything.
Well, that's interesting. That's an interesting point, though, because you have both done a lot of research on it, and you kind of inherited it, right?
I mean, it's been around a while. It's taken off as a much bigger concept in the last decade or so. I think especially since the Paris Agreement. With the Paris Agreement, there was this specific kind of reframing around keeping global warming below a specific level. And we also know that if we keep emitting, even at relatively low levels, we would still have some warming. So the Paris Agreement really implies reaching net zero at some point anyway. And I think that's kind of part of why it's taken off, and policymakers have started talking a lot more about net zero as a result.
I agree with Andrew there that it has definitely become more popular since the Paris Agreement. But I'm really starting to think, like, was it even mentioned before the Paris Agreement? It must have, but likely not in our circles, likely just more in political circles.
So, I mean, Zach has just turned his laptop round meaningfully, and he's highlighted a passage that says, by late 2014, net zero had gained traction, appearing for the first time at a UN climate conference, the UN's emissions gap report, and in a speech by the World Bank president. Yeah, mid-2010s, we think.
Yeah, and that's 1 year before the Paris Agreement as well.
Yeah.
So makes sense.
So that was nicely timed. Don't get me wrong, I think net zero is, something we absolutely must be striving for everywhere. But it would also be great if we just stopped emitting anthropogenic carbon.
Well, this leads me to what might be a blindingly obvious question for some, and a mystery for others. Why do we need to reach net zero?
Yeah, to stop warming the planet. I mean, so our emissions are at really high levels, and we know the more we emit, the more we warm the planet. So we can't just keep doing this indefinitely. And the longer we kind of put off actually getting to net zero, the more we warm the planet and cause much worse impacts down the track.
Some people might have found this episode as their first one and be like, who are these guys? Why is warming the planet bad?
Oh, that's a lot of reasons.
That's a lot, yes. Where do we start?
Exactly.
Go, Andrew.
I mean, we know there are so many aspects of the Earth system where warming the planet makes everything worse. Lots of ecosystems. There's so many reasons. It's
too many reasons to even remember.
Yeah.
But I mean, broadly speaking, I'm thinking of the hotter the world gets, the more energy there are in destructive storms, heavy rainfall, droughts, crop failures.
Heat waves, fires, death. Bad things will happen, to quote someone who should not be named.
And not just the effects on the Earth system, but the knock-on effects to our political, cultural, agricultural, economic norms, right?
Yeah. Climate change is having pervasive impacts. It's everywhere, and it gets worse the more we warm the planet, the more we push the planet away from its kind of pre-industrial state. So I think quite a powerful incentive to try and get to net zero ASAP.
Sounds reasonable.
But I think it's also worth highlighting that carbon and greenhouse gases in the atmosphere have a cumulative effect. So it's not just the emissions we do today or yesterday or even this year that causes the warming that we will see. It's everything that's built up over time, like literally all the way back to the Industrial Revolution. So the more we put carbon in the atmosphere, the bigger that pile of carbon grows, and it just sits there for a long time, which then means there's more warming to deal with, which just makes things so much harder.
Aditya, you mentioned a little bit earlier that there are natural sources of removing carbon from the Earth system, and then there are also, man-made solutions. Can you tell us a bit about how carbon gets removed from the atmosphere?
Well, one of the obvious ways is trees. When we plant trees, trees take up most of the carbon dioxide that we emit. Ocean is another form of a natural carbon sink. Oceans absorb most of the carbon dioxide that we as humans have emitted. So these are some of the natural sinks, the land and the ocean.
And when you say carbon sink, that just means something that stores or removes and stores carbon.
Exactly, yeah. And us as humans would be at the moment an overall source of carbon, so carbon source. So these are some of the natural ways. The man-made ways are still being developed. Well, one of the ways is humans doing reforestation and planting more trees or changing the way they use the land. So the land use changes. So to make the uptake from the land more efficient, by humans can do that as one way of artificially changing. But other ways are more focused on emerging technologies, like what we call carbon dioxide removal technologies or CDR technologies. And these are still new technologies that are still in research phase or like really early forms of technology, new technology.
Would that also be carbon capture and storage, carbon sequestration? Is that all basically the same thing but under a different name?
Exactly, yeah. It's like direct air capture, so taking out carbon from the air directly at the emission source, or biomass energy and carbon capture and storage.
And feel free to anyone to take this question if you're familiar with it, but how are those technologies looking? Like, is that something that we can do realistically at scale yet, or is it still experimental?
Would you like to?
Sorry, if I don't laugh, I'll cry.
That's what we call in Scottish football. That's called a hospital pass. You know, you give the ball to someone in such a way that they're about to be crunched.
Yeah, we're not in a good place at the moment. At the moment, I mean, there's a lot of work going on to try and develop these technologies. Lots of people working in this area. I mean, in terms of things like direct air capture, it's kind of some early technologies that kind of work, but it's very energy intensive to the point that it's not viable.
Yeah.
And I guess the other aspect is it can't just be capturing carbon in a way where it can be released again over like the following few years. It has to be a durable, permanent store. Yeah. And that's hard. So that's why people are looking at things like trying to bury it, deep into the earth and
just forget about it, sweep it under a really big rug.
Like nuclear waste.
Yeah.
I guess.
I wanted to go back to the ocean being a sink for carbon that you mentioned, Aditya. Do we know how much carbon roughly is absorbed from what we emit into the ocean? Because I don't think a lot of people would necessarily be familiar with that.
So majority of the carbon that we actually emit is taken up by the oceans. I think the numbers are around 60 to 70%, if I'm not wrong.
Okay, all right.
It makes sense because more than 2/3 of the planet is the ocean. We have large ocean basins. The Southern Ocean, particularly, which is so close to us, is one of the largest sinks of carbon because it's so big and pretty much covers the entire Earth in terms of the width of it. So extraordinary amounts of carbon is taken up and then stored in the deeper layers of the ocean.
So is there any risk that eventually, maybe, the ocean will stop being a sink and start emitting carbon because it just gets too full?
Yes, there is. So this is something that is a very central part of net zero research today and will continue to be, I think, for a while. Ocean, when it takes up carbon and as it heats, it expands and becomes more acidic. A more alkaline ocean is a better carbon sink. But if it starts becoming more acidic, it becomes less efficient in uptaking carbon. And also, a lot of the heat and carbon dioxide that the ocean uptakes, it stores it in the deeper parts of the ocean. But because the ocean always circulates, it's dynamic, it keeps moving, there's a risk that a lot of the heat that is stored will start to be released in the future. So combine that with the fact that the efficiency of it taking up carbon decreases over time as well, it becomes less efficient.
I was just going to say, is there an ETA on that? Do we know roughly when that might start to happen?
Good question. No. I think processes are so complex that we are still, as a climate community, we're still working out exactly what the timescales and the way these complex processes work together.
Yeah.
So giving an exact time is very difficult.
But we don't want to get there if we at all can avoid it.
Exactly.
Most British bathroom sinks and baths have this little emergency drainage hole at the top of the bath or the sink. And I remember when
I know what you're talking about.
When I was younger, I'd say to my mum, "What's that?" And she's like, "Well, that's there just in case the sink or the bath gets so full that instead of overflowing and flooding the bathroom, it goes into that gap." And I was like, "Oh my God, can you imagine such a crisis?" You know, like it was a terrifying prospect.
Wow.
And then as I got older, I started to push the limits of, you know, exactly how much you could fill up the bath or the sink, and being like, let's just see what happens, you know? Imagine if it went down the emergency sluice. Basically, where we're up to is, you know, we're pushing the Earth's carbon sink oceans towards the limit, but we don't have the emergency sluice.
So we don't have an emergency sluice. Is that what you call it?
I'm calling
in
it a
our
sluice.
bathtub?
You know, I've picked that word out of my vague knowledge of dams and water storage.
Okay.
You know?
Don't even know it.
It's actually a very common analogy that is used for net zero. Like how much water you're putting into the bathtub versus how much you're taking out is essentially how much you're emitting versus how much you're taking out. And coming back to the point of like emissions and balance and, you know, carbon dioxide removal technologies, I think we also nowadays with these emerging technologies focus a lot on the taking out part, where we don't focus on the putting into the atmosphere part. And there's a solution there as well. So you can reduce this end, putting into the atmosphere. And that's the most cheap and viable solution that we have today.
Well, I was going to ask, actually, I know Andrew's already mentioned how the carbon capture and storage technologies are not that effective yet, but how much are we relying on them in our future projections of national and global net zero projections and carbon budgets?
I do feel I'm getting the hard questions, so that's okay.
Yeah.
Sorry, what was the question?
And the question's so hard. The question's so hard that it's overflown the information sink. The question was, how much are we relying on carbon capture and storage in our long-term or medium-term net zero budgets and you know, assessments of our remaining carbon emitting capacity?
We're now constructing scenarios for the next set of major climate model simulations, and some of them have lots and lots of carbon uptake happening.
Even in our models?
Yes, in a sense.
In the information we're inputting into them.
It's being kind of forced into them in a sense. Yeah,
we're telling them to take up all that carbon because we're assuming that it will just happen.
It's being awkwardly shoehorned in, like my jokes in each episode.
Very similar.
And your Simpsons references especially, yes.
Yeah. For lots of things, you wouldn't want to plan something based on something that doesn't exist yet. And that's, in a sense, what we're doing here, in that we're talking about net zero, even going beyond net zero and actually having net negative emissions. And we are quite far away from that. As Aditya was saying, at the moment, it's so much cheaper and easier just to reduce our emissions than it is to do any kind of substantial additional kind of uptake of carbon. But we are going to have to develop these technologies. And I think the hope is that human ingenuity will get us there.
But at the moment, we're sort of having our cake and eating it, right? You know, if we rely on future scaled up carbon capture and storage, then it's much easier because then we can also keep emitting.
Yeah, we're passing the problem on to the next generation, essentially, at the moment. We're assuming we'll be able to do this.
I wanted to ask about trees. So I have read a little bit that some of the world's forests that act as carbon sinks are getting to the point of soon no longer absorbing carbon dioxide, but indeed emitting it. Are either of you in a position to comment on the sitch there? acknowledging that you're not specifically tree people. So you might want to duck it.
I actually read about this a few days ago. So there's been a recent paper and recent research in Australia, actually, that many of the forests in Queensland have turned into a net carbon source rather than a sink, which is really interesting. And I thought this is a little bit scary, considering that these are large forests that are a huge carbon sink, particularly in Australia. There's still like major forests around the world that are still an overall carbon sink, and they are in danger of large-scale deforestation. I'm thinking Amazon here, and there's a risk that if these large forests turn into a net carbon sink, that this could be potentially have a massive impact on the time that we take to reach net zero, for example. There's also the risk of wildfires. So wildfires and bushfires can damage large-scale forested areas, and they add to the net carbon emissions in a given year. And with climate change, these risks will increase over time. And this means that overall, we can have more wildfires in the future in a given year, which means more emissions. And this sort of becomes like a negative feedback in a sense.
Yeah, and a large-scale bushfire is like a double whammy, isn't it? Because you lose the capacity of the forest to store carbon, and all the carbon it was storing is emitted immediately or very quickly.
Yeah, exactly.
So a not so fun fact for you, the 2019-2020 wildfires here in Australia during our Black Summer emitted more carbon in those fires alone than what we usually see in an annual cycle in Australia from anthropogenic emissions. So it just goes to show the scale that one fire season can have on emissions.
Yeah, scary. And as you say, not so fun fact. I wanted to talk about the different types of greenhouse gases. So when we're talking about net zero, we're not just thinking about carbon dioxide, right?
No, not really. So most of the scenarios that we were talking about earlier, they sort of look at mostly net zero carbon dioxide, for example. But I think the general perspective from a policy making standpoint, I think we never talk about net zero in just carbon dioxide. When we talk about net zero, we're talking about greenhouse gas emissions across the board. So that includes methane, and other carbon pollutants. Some of these other greenhouse gases, they have a larger potential for warming. For example, methane can cause much more warming than carbon dioxide. So the near-term benefits of reducing methane emissions, for example, would be massive in terms of the cooling potential that it might have.
Yeah, so my kind of lay understanding, and I'd love to be corrected if I've got this wrong, is that methane is quite sort of potent but short-lived, whereas carbon dioxide's naughty because it hangs around for even longer. Is that right? Andrew nods.
Yes, basically. Yeah. So with net zero, people do talk about CO2 or combined greenhouse gases. CO2 is a bit easier to think about and deal with, and it's kind of one gas and it hangs around for a long time. Whereas if you're thinking about combinations of gases, it's just more confusing. But yeah, that's basically right. So methane, you get quicker benefits if you reduce methane emissions. And that's partly why a few years ago, there were pledges around trying to reduce methane emissions more quickly to try and get that quicker benefit.
Okay. I'd like to move to the next segment. And because Andrew has the mic in hand, I'm going to ask Andrew a question. Does it matter when we reach net zero?
Yes, I'd say so. So
elaborate.
It matters both when we reach net zero and how much carbon we emit before we reach net zero. The more carbon we emit before we get there, the higher the peak global temperature will be, and the worse the impacts will be. And obviously those kinds of things are related. Like if we delay reaching net zero, that in most scenarios would mean we're emitting more carbon before we get to net zero. And we've done lots of model experiments with the Australian Earth system model to try and explore this in more detail. And Sarah and Aditya and I have done our own analyses of these experiments, looking at different aspects of the climate and the consequence of delay in getting to net zero. And it's stark. I think, it really is. It's scary. Like even a few years of delay can make quite a big difference. Decades of delay, leads to much worse outcomes, even in centuries' time, for things like heat waves, as Sarah has shown, and also things like sea level rise, the amount of ice around Antarctica just stays less for longer if we delay. What we're really building here is like a lot of evidence to show that we need to get to net zero as fast as possible. Otherwise, we're just burdening the next, not even just the next generation, but next many generations with much less hospitable climate.
Can I just say, like, it was working with net zero simulations, so the work I've done with Andrew and Aditya, that's actually changed my perspective of climate change. So when I got into this field, like climate change was obviously happening. You know, we didn't have any sort of emissions reduction targets back then. And, you know, it was all doom and gloom, which is not so great. But then we've hit this point where we're like, okay, well, let's reduce our emissions and let's, you know, aim for net zero. That was for me at least, a brief moment of gratefulness and thankfulness that this was going to happen. But then looking at what actually happens to the climate has been a really depressing experience, because things unfortunately don't just magically get better when we get to net zero. And even for a climate scientist, that's a really hard thought to have, or, you know, hard perspective to live with.
I mean, thinking of a human analogy, it's maybe a bit like if you spend half your life smoking a pack of cigarettes a day and then you stop, you're going to get some short-term health benefits from stopping smoking, but there is a lot of locked-in damage that may well arise over the rest of your life that you've got yourself in for, right?
Yeah.
I used to smoke.
I think it is quite a reasonably good analogy. And also that it's better to stop smoking than delay stopping smoking for a few years. Like, you'll have better health outcomes if you stop smoking earlier.
Let's talk about this concept of carbon budgets. You know, how much carbon we can afford to burn before we get to net zero. What's the dealio there?
Basically, the less, the better. As we were saying earlier, the more carbon we emit, the more we warm the planet, and it's roughly like a linear relationship.
What's the numbers? What's the equation roughly?
Do you remember?
No, something to point
you
to me.
guys,
Aditya's
got it. Aditya's got it.
Oh, good. This study's been ruling my life lately, so I should know it.
Yeah, I think the number is somewhere around 170 gigatons on a global scale of carbon budget. So CO2 equivalent, as Sarah said, of 170.
We've got 170 left to go.
Yes.
Any more than that, and we're totally cooked.
We're totally cooked, yes.
Jinx.
And this is to stay within the Paris targets, of course, which
1.5 to 2.
1.5 to 2 degrees, yes.
Let's just kiss 1.5 goodbye. Can we just all be realistic? Like, sorry, not aimed at anyone on this call or anything, but, you know, the last 3 years when averaged together have exceeded 1.5 degrees Celsius. I think we just need to be realistic about how tough the road is ahead.
What would you all, the three of you, what would you take right now? If someone said to you 2.5, would you take it? It's like, it's like higher or lower, right? You guarantee.
What do you mean? What do you mean by take it? Like,
what I mean is
right,
like
that's
an omnipotent being says to you, right? I'll offer you stabilization at 2.5 from 2050 onwards, or 2100 onwards, and it'll never get more than 2.5. Do you take it now, or do you gamble on doing better than that or worse than that, based on everything you know about humanity and our society and our politics and our economic habits?
Take it.
Very, very interesting question. I don't know. In that hypothetical, I guess I take it. But the good thing about not being hypothetical is that it's not a binary choice, I think. The main point is that we should emit as less as we can right now and try to stabilize as low of a temperature that we can, and then try and get back to 1.5 in the future.
See, this is the thing. That's what makes me think, like, take it, because of all of what's happening in the US and the decades of work that's being undone in months. Like, the proof is in the pudding, right? Like, we have to do the work, and no one's doing the work fast enough. And in some countries is actually being undone. So that's what makes me say 2.5, because hopefully things don't get any worse than what they are in certain countries. But if they do, then even 2.5 really seems out of reach.
This leaves Andrew with the casting vote in my little higher or lower experiment.
I wouldn't take it. I actually, I have a bit more maybe misplaced faith that we'll do something at some point soon.
I'm just old and jaded, I think.
I mean, 2.5 is still like bad as well. Like,
I know, yeah.
I think I'd take 2.
Okay.
But not 2.5. Like, 2.5 is like the reef's fucked.
I mean, the reefs are gone anyway. The reefs are gone. Just for anyone listening at home, the barrier reef is gone. Stunned silence. 2.5 bad, 2 bearable.
Some people would argue it's still, not bearable, but it's a lot better than 2.5. I was going to say, it's maybe worth going back to, Nerali's paper, which we've talked about.
Yes.
And you've got the previous podcast on, because even a tiny, tiny increment of global warming has substantial impacts, really negative impacts. And it is, then quite stark to then think, 2.5, like that's a massive difference.
Yeah, what was so? I mean, for anyone who hasn't heard that episode, this is our colleague or your colleague Nerily Abram led a paper calculating what the impact of a new liquid natural gas project off the coast of Western Australia would be on warming and then on human lives and the Earth system. So coral reef die-off, deaths in heat waves, that kind of thing. And that was, what degree of warming what was that? Can we remember? Like
0.0039 degrees Celsius.
Like a very small fraction of warming led to a lot of people dying in heat waves, led to a lot of
484 in Europe.
484 in Europe.
2100.
A lot of coral reef die off, that kind of thing. And I'm just being there like, 0.5, take it or leave it.
Exactly.
We're not taking these things lightly either. But I think that can be flipped the other way though, right? If we do stop another fossil fuel project going ahead, or a country does cut their emissions by 10 to 20%, that does mean a real reduction in potential warming, which means a real reduction in impacts. So it can be flipped that way, that every little bit counts, both in terms of the negative, but also in terms of the positive.
She's back on message. This is it. Thank goodness for that. And so that now leaves me with the capacity to make a segue to our next serious question without it being extraordinarily disjointed. I would like to know how much work has been done studying our various potential pathways to net zero. I know that that's what you two are doing a lot of, but is this a common thing around the world of climate science?
There is a lot of work on scenario construction and like looking at different possible pathways, but there's a lot less work on the implications for the Earth system and the climate from those pathways. And I should say, like the model simulations that we were talking about before with the Australian Earth system model, those are not like realistic pathways. They're just testing the question of, if we have delay, what happens. But there's surprisingly little work on that topic, I think. I find it very odd, actually, given we talk so much about net zero now. It's always in the news, but it's always viewed as kind of almost like an end point. But we also know, like from emerging research, including our own work, that there's still a lot of embedded change beyond net zero. And the path matters a lot. And I think a lot of people and policymakers just don't quite get that yet.
And I think certainly more than we realised as climate scientists too, because we would, and I'm guilty of this, would say, in 50 years maybe it'll get better, so in my kids' generation. But what we've seen is that if it's going to get better at all, it's not for hundreds of years, perhaps even over a millennia. And that's something that we need to face and be realistic about, and not just assume that net zero is the panacea that we all wish it could be.
I'd like to ask about expected emissions. And I read in a conversation article, I think you've done one or two of those, Andrew.
How many has he done now? Like, I know he celebrated his 100th milestone or birthday or however you want to
That was at least a year ago.
Where are we now?
So it must be 150 now, right?
I don't think so. I don't know. Maybe like 110.
Zach, can you fact check this?
we don't need a fact check.
That's a brag check.
Yeah, we do. You just breathe them out, I think.
The one in question.
Self-organized.
The one in question was, I think, also featured Thilo Zine. Thilo Zine at CSIRO, and it was about expectations. It mentioned that emissions could peak in the next few years, and I'm just wondering what the mechanism is for predicting when global emissions may peak.
This is slightly outside our areas, I think. It's because this is really, it's partly socioeconomic. And I guess what we've seen over the last few decades is global greenhouse gas emissions have still risen. 2025 had the highest global annual emissions on record, very far away from net zero still. But the rate of increase has kind of slowed. And, we've seen with events like COVID that it can drop quite a bit. So I think it's, some modelling around this, economic modelling, seeing what individual countries are doing. And there are lots of countries now with reducing emissions. So you can kind of build models around this and predict, hopefully, that emissions will have peaked or be peaking.
And I presume a lot of that modelling is around the price of renewable energy relative to fossil fuels. which is kind of changing in favor of green energy in some cases.
Yeah, as I say, this is not really my area, but that's yeah, I think that's how it works. Yeah.
It's so it seems that China's emissions have peaked, I think, over the last 18 months or so. This is unconfirmed, but there are articles around on this. They haven't gone up. So it looks like China may have peaked, and they emit roughly a third of global emissions. So that's a good sign. But in Australia, a lot of our emissions reductions has actually come from how we treat the land surface. Around mid-2000s, we stopped doing as much deforestation as what we used to do. And that, with the replanting and everything, that's actually, led us to net zero. But we've only done a little bit in terms of actually reducing our emissions, and that's mainly through people getting solar on their roofs. But even then, there's been increases in other sectors.
I guess I'd just like to add to that. I think the good news in that sense is that a lot of the developed nations have sort of peaked and are starting to go down in emissions, Australia being one of them, of course. But the problem in there lies that we adopt new greener technologies, but at the same time fund new fossil fuel projects. So that's the dichotomy that we are living in today. And one has to
but that's fine, because we just ship that overseas and they count for those emissions. So they're not our emissions. It's fine.
Sarcasm.
Just in case anyone couldn't tell.
And I think in the modern day, it's the developing nations where the emissions are still rising. And when we reach net zero, the pathway to that depends on what the developing nations do. And this is where, a lot of international cooperation, collaboration with, the emerging nations in Africa or Asia comes in, so that they can actually adopt these greener technologies early on in their development, so that they don't have to take the detour to fossil fuels and then come back, which the developed world did. So it's based on this pathway, the future of net zero, and when we reach and what happens sort of depends.
And again, I mean, this is well outside all of our area now, but we can still comment on it.
Absolutely.
I think there's a moral and an ethical imperative for developed countries that developed industrially and economically by burning fossil fuels and creating the climate crisis to support the developing world in developing economically in a sustainable way. Well, I don't know if that's actually happening. Yes, but is it happening? Sort of,
No.
Not really.
No, and I think another part of that is also the impacts of climate change are bigger in the developing world, in the tropical regions where they were not the biggest emitters. And, this is where a lot of loss and damage, the concepts of that come in. And it's a tricky thing, for policymakers and governments to work on. But this needs to be the focus going forward.
And the great news is for listeners at home, we have an accidental double header today because we're speaking to Joyce Kumite tonight from the Imperial College of London, who is an expert both in attribution of extreme events to climate change, but also on loss and damage and climate justice. So we'll be able to follow up some of these things on this very evening. And
will the episodes air back to back?
They might well do, actually. They probably should do, yeah. But I will not make the mistake again of scheduling 2 recordings in one day because that was an accident.
Yeah, we'll be exhausted by the end of it, but that's
now,
okay.
Speaking of overcommitting, Andrew, perhaps
I've never heard of that expression before. What does that mean?
Speaking of overcommitting, Andrew, I would like to ask you about the concept that I've read in relation to net zero, which is overshoot. Can you tell the folks at home what we mean by that, please?
Yeah, so it's becoming increasingly clear that, and Sarah already alluded to this, that we're going to go through the 1.5 degree.
She didn't allude to it. She drove through it with a bulldozer.
Yes.
Subtlety like a sledgehammer. Yeah.
I mean, unfortunately, we've already had a year of above the 1.5 degree mark. We're going to go through the 1.5 degree mark properly. And to actually meet the Paris Agreement targets to limit long-term climate damage, we're going to need to bring global temperatures back down. And we also know that reaching net zero probably isn't really enough to do that. It goes back to the point that the carbon hangs around in the atmosphere for a very long time. So even if we reach and stay close to net zero, a lot of things get worse. So the hope really is that we're going to have net negative emissions, which means that human activities are actually pulling more carbon out of the atmosphere than we're putting in. And we're a very long way off that. But if we did achieve net negative emissions in a substantial way, we should actually cool the planet back down. And that would constitute kind of overshoot. We've gone over a target going back towards it by pulling the carbon out of the atmosphere more than we're putting in.
Net negative would be very positive.
Net negative would be very positive. I always, when we talk as well about feedbacks and negative and positive, it's always confusing. It's not the same as
Do you remember
positive
good and bad.
feedback amplifies the response. Negative feedback reduces it. And there's always that moment of like, what?
Fairly early in the pandemic, when Trump first had his first test for COVID, and I think he got off the helicopter that the president has, and the press were gathered around him, being like, what was the results, Mr. President? He's like, I tested very positively, and that it was negative.
And everyone's like, back
What?
away.
Oh, Zach has a moment of interjection. Zach's putting the recording up like unruly children. I'd like to talk, if I may, about what happens beyond net zero. So after we reach net zero, what will happen to the Earth's weather and climate?
Big question. I mean, so we've done some work towards understanding this, but again, that's kind of under specific model simulations where we stay at net zero. So it's kind of assuming that we're not really able to go net negative in a really big way. But if we did stay close to net zero, we're talking about ongoing sea level rise, ongoing warming of the Southern Ocean, particularly. Sarah's work shows worsening of heat waves in some areas of the world, I think particularly Australia, Southern Hemisphere. And our part of the world would probably suffer a bit more in a post-net zero climate than, say, parts of the Northern Hemisphere. I guess if we were to properly achieve net negative emissions, we would see some more benefits and possible, heat wave reduction on land, at least if it was substantial net negative emissions. And at the same time, though, sea level rise is kind of, locked in really. It's not as bad if we get to net zero sooner and actually achieve net negative emissions, but it's still, sea level rise itself would continue for a long time to come. So
why is that? Is that because the ocean, I don't know, continues to expand, or is it more about glacial melt and ice sheet melt that it just that mechanism's already started? There's already inertia in that mechanism.
It's both really. It's the ocean is just slow to warm up through the depth as well, and contributions from ice melt, so which is also quite uncertain, it should be said. But I know that's probably not like a neat answer to your question. I have
many more questions on what will happen after we reach net zero. Let's take the awkward spotlight off Andrew for a minute. And I will ask Aditya, are there likely to be differences between the Northern Hemisphere and the Southern Hemisphere beyond net zero?
Yes. I think, as Andrew said, these are results from few model simulations, but I think there's a lot of physical basis behind this as well. There's expectation that when we reach net zero, most of the Northern Hemispheric land areas, they will cool down versus Southern Hemisphere, which is mostly its ocean. Because it's the inertia in ocean, it will continue to warm, and even if we reach net zero. So there's a big contrast between the two hemispheres, yes.
You mentioned about the models there, and this might be something that people don't know much about and are curious about. So climate models are, computer equations that tell us about what the Earth's weather and climate is doing and will do in very, very simple terms. Andrew's like, well, not really.
No. I think we need an episode on this, actually.
We will have an episode on it. We will. When I find someone brave enough to talk about climate models for an hour and a half or 2 hours, open to invites.
But everyone's sick of me.
Okay, we'll do it. We'll do just the two of us one. And then all the climate modelers will come up to you in all the conferences and be like, you were wrong about this and you were wrong about that.
Yep.
That's not what they sound like. My question was going to be, what was my question going to be? Oh, climate models, right. So how do you change the inputs or the parameters of climate models to learn about net zero? What kind of things do you have to do to it to get that information?
So I think one of the ways in which we do that, so traditionally what climate models used to do is they used to prescribe concentrations of CO2. So you would actually tell the model, this is the amount of CO2 in the atmosphere, do your thing. But now we are moving more towards what we call emissions driven. So now we prescribe emissions. So we know, we have a sense of how much emissions there are globally or locally in different regions, in different countries. So we tell the model, okay, this is the emissions that you have. And then we tell the model, try and balance this in your model. How much is taken up versus how much is being stays in the atmosphere. And then when the balance is achieved, that's when you get net zero. And that's precisely what the model is doing, is that you have these components within the land, the ocean, which are trying to balance the overall emissions. I think this was an oversimplification, of course.
We like that. That's what we're here for. We're here for simple and accessible and entertaining.
No, that was great. That was really good, Aditya.
And you mentioned, Andrew, that things might be a little bit worse here or harder in Australia than elsewhere. Can you tell us a bit more about why that would be?
It goes back to what Aditya was saying with the oceans having more inertia. And, here in Australia and generally in the Southern Hemisphere, we have so much more ocean. Around Australia, we have ocean, obviously, and our weather and climate is influenced by the oceans. And I guess people see this all the time with El Niño and La Niña. That's kind of a really obvious influence from ocean variability. So if we have warming of our oceans continuing for a while around Australia, that will have impacts. It'll have impacts on temperatures, on rainfall as well that we experience. And I don't think we have a really good handle on this yet. There's a lot of legwork we need to do to properly understand this, which is, it goes back to kind of my more general surprise that we don't really know much about this topic yet, given it's what we're actually targeting achieving.
Who's going to do that legwork?
Guess it has to be us.
Okay, not me.
No, not you. Do you want to go and analyse the model?
I can't. I literally can't count. They wouldn't let me in.
No, you can't count, can you?
No. Yeah. Can we talk about the Arctic and the Antarctic under net zero? What does it look like for the polar regions? Do they differ from each other? Yeah, what do we know about that?
So, they do differ. I mean, so firstly, we know in our warming world, the Arctic, we're seeing big reductions in sea ice and a growing likelihood of sea ice-free summers. And in our projections of kind of net zero climates, it looks like, if we were to achieve net zero emissions, Arctic sea ice stays roughly at whatever level it is when we stop emissions. It does, we get lots of year-to-year variability in Arctic sea ice in the real world and in our models, and that stays. But there isn't really much of a trend under net zero emissions in Arctic sea ice. So not really recovery, but not really worsening either. But the Antarctic's a different story, and it goes with the Southern Ocean warming as well. So Antarctic sea ice has followed a more complicated path over the last few decades. It kind of didn't really decrease until it did. About a decade ago now, it started.
And pretty severely too, I remember. It was just it seemed like a sudden shift.
Yeah, really dramatic change. And in our net zero scenarios, we have continued decline of Antarctic sea ice, even under net zero emissions associated with that warming around Antarctica. I guess one caveat to this is most models don't really capture some of the observed kind of variability and change in Antarctic sea ice. And there's lots of work going on in the centre around kind of trying to understand that better. So then, there's a question about how much you trust models that don't do that properly. But I think in general terms, it makes sense that Antarctic sea ice would continue to decline if we stay on a path that's very, very close to net zero. Just because of that warming of the Southern Ocean. There's a nice paper by some of our CSIRO colleagues that compares the Southern Ocean to a freight train. So,
interesting.
Another analogy. But, the idea being that once it starts, it's so big and heavy, it's like if a train puts on, a really heavy train puts on its emergency brakes, it takes, it's a few kilometers before it stops.
You don't want to be parked in the way of that.
What about tipping points? So I don't actually think we've done an episode on tipping points yet. I think we have one planned. But these are things, where if emissions reach a certain level, they can really start to do some nasty, slightly unforeseen or unknown damage to the Earth system. So permafrost melting, major ocean currents slowing down or failing altogether. Have you done much research on the interaction between reaching net zero and when and how and what the impacts on these tipping points will be? Whether we can stop some tipping from happening, or is that a bit beyond the remit of what you can do at the moment?
That's a really big question.
That's what I get paid the medium bucks for.
It's something scientists should be able to answer, and I don't think we can yet. I think there would be a general view that the longer we wait to get to net zero, the more we risk, triggering some of these tipping points. But I don't think we could say much concretely. There is some work being done. There was a nice study done in Switzerland around which kind of identified some non-linear changes under net zero scenarios. Yeah, there's really very little work around this topic at this point.
From my understanding, and I don't know much about tipping points, like from a research perspective, they are really hard to model. And then, with this world of net zero and what life looks like after net zero being so new, we still just don't know. Like Andrew said, we can assume that earlier net zero means less chance of tipping points. Whether or not those tipping points can still occur in a post-net zero world and how long into that, I don't think anyone really knows yet.
Could be a niche for someone to enter.
There's another centre of excellence.
Or just a PhD student, like a certain person who specialised in heat waves and certain people who specialise in net zero have carved out little niche for themselves. Maybe the net zero tipping points person could fill a little void there. I
think we need more than one person to answer this question.
I'd like to talk a little bit about your motivation for studying this area. So, Aditya, what inspired or encouraged you to start studying and exploring net zero?
Yeah, I can remember when I had the meeting with Andrew for the first time when I was starting my PhD. I didn't even know this type of research existed. This is the first time when Andrew sort of put the idea in my head, there are these runs, there the concept of net zero and net zero emissions. And looking at the climate from that perspective, all I had known about was the older scenarios, these high emission future pathways, which I realized when I had that meeting that does not align with what most of the policy decisions people make in terms of the Paris Agreement. And this made a lot of sense. And, being someone who is a young climate scientist, it made sense to try and understand, and who loves physics and math, and it made sense to try and understand how the world would change in where we reach this sort of a target, and what would it mean if we were to temporarily exceed the target of the Paris Agreement and stabilize temperatures in a world which is much warmer than 1.5 degrees or 2 degrees. And I was curious to learn that, and it was the perfect project to fulfill my curiosity, I guess.
And what about you, Andrew? Because, going right back to the start of this conversation, we identified that none of us are quite sure when we first heard this term. When did you start to find yourself doing this kind of research on it, which is, still quite rare?
So I think I started working in this area maybe about 5 years ago. And, previously I'd done more work around extremes and attribution like Sarah had as well. And I think I just became curious with all this discussion around net zero that I think I remember trying to find papers about this and actually what the climate would do beyond net zero and just not finding very much at all and thinking, well, that's odd. So trying to fill that big gap. We know, having done some work on this topic, we know that policymakers are really interested. So we've given presentations to people in Department of Finance, Victorian government, Climate Change Authority, and also some politicians as well. So it's something that is a topic of interest. And I think it's also expanding globally as well. We're seeing much more emphasis on trying to understand how the climate will change beyond net zero. And indeed, there's a chapter in the next IPCC report that's focused on partly that and overshoot as well.
Is that the first time that there's been a specific chapter on it in an IPCC assessment report?
Yes. Yeah. So that's quite a big moment in recognition of how important a topic this is.
We should actually clarify, because I'm not sure I did earlier, that's the Intergovernmental Panel on Climate Change, which is the UN-backed authority that convenes scientists around the world to give an update to elected officials and the general public on the current state of the internationally agreed scientific consensus on climate change.
We synthesize the most recent literature compared to the previous IPCC assessment report. Synthesize is the key word. You need to write a synthesis.
Which is different from a review.
Yes, it very much is, as I'm learning. So we've talked a lot about the simulations we've done here in Australia with our climate model. Aditya or Andrew, what are the other simulations that exist across the world, or the other research, I guess? Andrew, you mentioned that when you did your original search, there was not much. Has that changed in the last 5 years? Is this field growing?
Well, I guess I'll give some thoughts of mine as well here. I think the Australian Earth System model is, in the global context, unique in the sense that it's, as I was talking earlier, emissions driven. So we're not actually telling the model this is the concentration of atmospheric CO2. There are many simulations around the world that are still concentration driven, but there are very few emission driven net zero or overshoot kind of simulations around the world. There are some modeling groups that are starting to do these things, but it's like very early stages. There are unique, what we like to call MIPS or model intercomparison projects, which try to compare different models in these different types of experiments. And there are these new MIPS coming out that will run these simulations and trying to analyze how the climate might change or weather might change in these sort of novel simulations. But there are very few models still.
You know, for people who aren't working in this space, please correct me if I'm wrong, but this is my attempt at a kind of super simplified explanation. So you mentioned Australia's Earth system model, and then different countries around the world have their own versions of climate models. Is the coupled model intercomparison project, CMIP or MIPS, that's these different countries getting together and saying, our model says this, your model says that. Let's kind of compare the results, combine the results, see what the outcome of this kind of compare and contrast is. Have I got that roughly
More
right?
or less.
Essentially, yes. It sort of democratizes the whole process where people can work with each other's models and try and compare them and understand why they're different, if they are different, or if they're similar, why they're similar.
So basically all these model groups submit these models. They just run them and then put them in this database, and then researchers like myself, Andrew and Aditya, go and analyze them and say how good or bad they are. Potentially, if they're good enough, use them to understand what's actually going to happen.
Nice. I would like to ask some questions about Australia's position on net zero, like as a country, particularly the government. So the Labor government that's in power at the moment at a federal level has a net zero target of 2050. The Liberal National Party, which is the opposition, agreed with that target for a while, but since the last election, they're trying to, or I think they have formally ditched it. They're claiming that they're still adhering to the Paris Agreement, but they don't have a net zero target. And you know, this is now your personal view rather than your professional expertise. But given
I've got many of these.
Oh, just you wait. You're the host, not the guest.
Get back in your box. Get back in your box.
But no. Honestly, everyone can chip in on this. Like, as you know, people who spend a lot of your time and expertise studying net zero pathways, understanding intimately what is likely to happen to the Earth system and how important it is to reach net zero as fast as possible. What do you think and feel when you see, political parties in Australia kind of kicking net zero around like a football? Yeah, Andrew.
Yeah, it's not good, is it? It's like debating the future of the planet, and it's crazy that that's a political debate. I think any delay to net zero is terrible for very, very long timescales. So it's really, at least for me, crystallizes which parties have kind of credibility around anything, actually, just because it's such an important issue. But it's really depressing that it's become a political debate when it's really, the science is very clear, and it's 2026, and it's incredible that this is still an argument.
Still somewhat up for debate, somehow.
Somehow.
It's still, not somewhat, it is. Hardcore is. They just need to pull their heads out of their asses and get on with it.
I'm interested to know what type of conversations do you have with family and friends about net zero? Are people interested in what you do? Do they come to you for information or advice, or is it something to be avoided at dinner parties? And, what's your experience of talking to people who aren't climate scientists about what you do?
I think people are always very curious. Like, for instance, when I first heard about net zero, I am someone who was actively doing climate science research. And I have to admit that I didn't know much about it. And when I talk to people like my friends or family, when I talk to them about my research, they're always very curious, like, what is net zero? Why is it important to reach net zero? And I know, most of my friends and family members, they know and they agree with climate change. None of them are deniers, of course, but...
What a relief.
Yes. Well, lucky
I'm very
you,
relieved.
hey?
Yes. And so they know that the climate is changing and changing rapidly in many different ways. But then they always ask, what will happen when we reach net zero? Will things be okay? And it's when I do the research and when I see the results, it's hard for me to summarize some of the things which I find and say anything positive about it.
What you could just do is, like, if someone says to you, Aditya, will it be okay after we reach net zero? You can be like, yes, eventually.
I actually do something pretty similar and go, we're all fucked, and change the subject very quickly.
That's not something similar. That's the opposite.
I laugh.
I prefer this version.
Don't dwell. Yeah, that's true. Me too.
Perhaps I can take that approach next time. But I remember, so my parents, I talk to them almost every day, and they are very curious about the kind of research that I do. And to them, I usually just say, it's important who we vote for, essentially. Because reaching net zero is, for better or for worse, it is a political decision now. And I guess it's important that we keep this in mind. The more we delay things, the worse it gets. Governments and leaders who actually have this at the top of their list of priorities are some of the people that we should be voting for and rooting for. And yeah, that's what I tell my friends and family members.
The next question has to go to Andrew. How do you think researchers are doing in their communication around net zero?
I don't think we're doing a great job yet. But it's partly the volume of research is quite small still. So there's not that much to fall back on. I guess the reason I say I don't think we're doing great is because most people don't really know very much about it still. There's often surprise. I've given presentations where I show, graphs of things like ocean temperatures post net zero that just continue to rise for centuries if it's the whole ocean.
You got me with that one early in my time at the centre. I'm like, I'm here to save the world. Who's this dude raining on my parade? You know?
But I've
How
shown
dare
this.
he?
I've shown this to, quite a few times, and it's always a shock. And so people just don't have that kind of. Maybe it's really hard because it's quite a negative message, really, and we don't want to be super negative. But at the same time, we have to be real and talk about the fact that we've already pushed the planet away from where it should be through 150 years plus of greenhouse gas emissions. It's not going to be easy to get it back to where it was, and it's going to be a very, very, very long time before everything goes back, if ever. But I think that kind of message, people just don't realize that, and people still, it's like what Sarah said, people kind of view net zero as a panacea, and it's not really. It's an important step on the way, but we will actually need to really be pulling carbon out of the atmosphere and trying to get things back. But
I think it's also been eye-opening for us as scientists as well, because we were also relying on net zero. We were also so relieved, I think is the best term there, for the Paris Agreement to actually be done 10 years ago. But to see what it's going to be like it's hard for us, and it's hard, like Andrew said, it's hard to communicate that. I now do it in every public talk I give now. I mention this, but still everyone just looks almost, I wouldn't say perplexed, but it's almost like, but hang on, we've been talking about net zero for so long. Everyone's put so much weight on it, and now you're telling us that that's not enough. It is really, a big concept to absorb.
I sometimes think that the scale of the climate crisis requires a solution on the scale of the kind of Western allies in the Soviet Union in the Second World War. It's like, right, we're not doing anything else until this existential threat is defeated. But then everyone is so focused on winning the war that who's actually thinking about what happens afterwards? Now, in the question of that analogy, people were actually thinking about that. The Marshall Plan was being prepared to support Europe economically recovering. But you're a bit like the economists thinking about how are we going to stimulate global trade and European recovery after the war. It's a big enough challenge getting people to stop emitting that I completely understand why it's awkward for people to be saying, oh, and by the way, even once we've done that, there's still a heck of a lot of trouble ahead. That doesn't mean you can't not do it, It's sociologically, psychologically, it's a really fascinating challenge.
Yeah, agreed. At that time, the world was really focused on the war, and now we've got so many different focuses, and we see that in the news right now. Climate change is never, it occasionally becomes a really big focus again, and it's something that most governments are thinking about quite a bit in the background, but it's still viewed as this long-term problem, and that's holding back a lot of action. It means that we're not seeing that exceptional, effort and that exceptional coordination. And it's, maybe goes back to the voting base as well. People don't understand that it's such a critical issue that we need to get on top of ASAP. So that's not how they choose who to vote for either.
Well, weirdly enough, we talked about China's emissions potentially having peaked or peaking soon. Obviously, they've burnt a lot of fossil fuels to industrialize, but they've also been huge adopters of green technology, both the technical development of it, but also rolling it out at scale. And there's a strange irony that China can afford to think in such long-term ways because they're not beholden to an electorate that works on short cycles. So
That's a
who
good
knows?
point.
Maybe a dictatorship might be able to solve this problem. That is the end of our scheduled questioning.
Oh, that was quick.
It wasn't that quick. It's been an hour and 25 minutes. Do you have anything else that you would like to raise, Sarah?
I don't actually.
Good.
So we've covered the difference between gross.
Well, that's the one thing we haven't covered. So, we'll add this in as a little Easter egg. So, after writing the run sheet for this episode, I then ran it through ChatGPT and said, "Is there anything else I've missed?" And it comes up with some weird shit. So, ChatGPT said I could ask what the differences are between gross zero, net zero, and real zero. Is that an actual question, or is that a typical ChatGPT hallucination?
So I haven't heard of gross zero, so I'm going to...
It's absolute bullshit, isn't it?
Have I was like, oh, this is a new term. Enlighten me.
But there is, I mean, net zero and real zero, there is that, those real zero is a term that's been used. So the idea is net zero being the balance of our emissions with our uptake of carbon, but it still involves emissions, and real zero being we really need to get to zero emissions.
Like not emitting anything at all.
Yeah, or at least, I mean, that's not actually practical, but getting as close as we can to not emitting in a substantial way.
So why is it not practical? Why? Why can't we challenge ourselves to not emit anything at all?
I mean, there's lots of things where like agriculture and livestock, we can't actually get to zero completely on that. So there's a few industries. That's not the only one. I get what you mean, Sarah. Like there would be, with things like aviation, maybe we should be thinking, really big to the point that actually there's virtually no emissions from air travel.
And even transport, we can do it for energy, more or less. Like there are ways we can reach real zero, gross zero, whatever the term is. But yeah, I do get your point around agriculture. That's much more challenging.
And maybe to conclude, what is coming next in your research into net zero? Perhaps Aditya, you might like to tell us about your PhD, which is underway.
Yes. So I have been looking at, and sort of Andrew talked about this, in Australia, we are affected by the phenomenon of El Niño and La Niña quite a lot. They both form a part of the larger system called El Niño Southern Oscillation. So I am looking at how El Niño Southern Oscillation changes in a world where we reach net zero emissions. And so to give a brief about won't go too much into detail about the findings, but what we find is that if we continue to emit carbon, of course, ENSO becomes more variable. So the swings between, say, an El Niño and an La Niña become stronger, and you get more extreme El Niño events, or potential for more extreme El Niño events in the future. But when you transition to net zero, these changes sort of persist at the level at which we stabilize our planet. And so that means that for centuries, there's an increased potential for extreme El Niño events. So that's sort of the basis of the main sort of finding that I get. And yeah.
So when you turn off emissions, whatever El Niño is doing at that point, or the ways in which we've changed it, is kind of set.
Exactly.
Yep.
Yeah.
You're stuck with the El Niño that you've messed around with.
Yes. And I think in the overall question, I guess, the fundamentals around even the global temperature response after net zero is still an active point of research. I think how committed warming are we committed to, how much warming we are committed to after we reach net zero emissions is still the uncertainty range, and that's pretty big. And I think going forward, future research is going to focus on trying to constrain the uncertainty in that value to try and see whether we are going to cool down or whether we're going to go warm, or whether the value is going to be zero, like there's no temperature change after we reach net zero emissions, for example. And that's a big uncertainty because we don't exactly know how land and ocean carbon uptake processes, how they work. It's still a big active area of research, and it's important that we try and constrain that value and try and figure out what these processes do.
And in between podcast appearances and conversation articles, what kind of research are you going to squeeze in, Andrew?
Well, he's not got much time. He's now Vice President of AMOS as well,
That's
Australian
true.
Meteorological and
And an
Oceanographic Society.
IPCC author?
Oh, no, not an IPCC author, but
Never mind.
But I have enough. Yeah, I have plenty of other commitments.
You're doing enough.
I guess I'm keen to try and fill in those gaps around what we know about a post-net zero world. And I'm fortunate to work with lots of students, including Aditya, interested in this topic. So Aditya talked about El Niño and La Niña, but other students are focusing on things like compound extremes and droughts in a post-net zero climate, and just trying to fill in some of those gaps. In terms of some of my own research, at the moment I'm looking at kind of what makes the Australian response post-net zero different from other regions of the world, and is it how different is it really, and how different is it depending on the exact pathways as well.
Sarah.
Yeah.
I think that's it for this episode.
We didn't, sorry, and a question that this is a bit of a contentious one, but you know how much I love that. In your view, is there a risk that net zero could become a loophole? So if we're going down the road of all of these carbon emission reduction technologies, could that potentially mean bad things? People could take advantage of that.
I guess we see through history that any kind of potential for a loophole, people will take advantage of. Yeah, I could see that happening. We already see that, I guess, with carbon offsetting.
Yeah.
There's a lot of kind of dodgy carbon offsets, and that's just kind of maybe a taster of what we might be in for. So, we know that any kind of carbon uptake has to be, durable, as we said, permanent to be effective, and that's hard to achieve. So I could see, potentially more temporary ones being touted as solutions when they're not really.
Right.
Cool.
We're going to
go depressing, but thank you. Well, actually, Australia's kind of already doing that at the moment. Hopefully this changes, but, we're saying that we're reducing our emissions when in fact we've just stopped cutting down trees. So there's just more absorption going into that natural sink. There's our loophole. We're good at that.
Look, you're there in Canberra, Sarah. You're the one who can sort it out,
Oh, man, if I had the time.
Let's thank both of our guests, Andrew and Aditya, for joining us on the show. It's been really interesting and fun to chat to you about this serious and important subject.
It really is.
That's it for today. Please join us for the next episode of Totally Cooked.
And we'll tackle the climate crisis together.
Great.